Okay, so we are in this lecture we will see the Laplace transform of the standard periodic and aperiodic function. So first is obtain Laplace transform of x of t equal to delta of t. So the delta function is shown in the figure below. So what is delta function? This is t. This t is equal to 0. It is delta of t, and this one is 1. Okay, now we have to write the equation for this. So it is defined as delta of t is not equal to 0 for t is equal to 0. This is equation 1. That is, at t is equal to 0, its value is 1. Okay, so according to the definition, of Laplace transform, x of s is equal to minus infinity to infinity x of t raised to minus st dt. This is equation number 2. Now here x of t is equal to delta t and its value is 1 only at t is equal to 0. So it is not necessary to take the integration. So we write here all this. Here x of t is equal to delta t and its value is 1 only at t is equal to 0. So it is not necessary to take integration. So equation becomes x of s is equal to t raised to 0 is equal to 1. This is equation. So equation 2 becomes this. Now therefore delta of t, its Laplace transform is how much? It is 1. Now we write the ROC for this. It is, since s term is absent in equation 3, ROC is entire S plane. ROC is entire S plane. So this is delta function, that is Laplace transform delta function is 1, and here is its proof. next is unit step. This is delta function. Here is unit step. So obtain Laplace transform of x of t is equal to u of t. Now we have to draw the unit step function. So u of t is, it is t, as t is equal to 0, this one is 1, function u of t, and it is, so it is defined as u of t is equal to 1 for t greater than equal to 0, and this value is 0 otherwise. So next is, now we have x of s is equal to minus infinity to infinity x of t e raised to minus st dt. But here I give continuous equation number, that is this one is 4, this is 3, 4, this equation is number 5. But here x of t is equal to what? U of t, which is equal to 1. So in the range t is equal to 0 to t is equal to infinity. Okay, therefore x of s is equal to Laplace of u of t, it is minus infinity to infinity 1 into e raised to minus s of t dt. Therefore x of s is equal to minus of e raised to minus st by s, 0 to infinity, it is minus 1 by s, e raised to minus infinity minus e raised to 0, so it is 1 by s. So Laplace transform of u of t is 1 by s. This is equation number 6. Now ROC, region of convergence. So ROC is the we write here Laplace transform of unit step. Laplace transform of unit step is 1 by s. We have calculated it, and it is for the range RE of s greater than 0. That means for sigma greater than 0. So ROC is sigma greater than 0. Now it has pole value at s is equal to 0. That is, at s is equal to 0 means that is at origin. Okay, so we draw here, it is sigma, this is j omega, pole is at the origin and towards the right side. So this is ROC and it is pole. Pole is denoted by this cross sign. So this is unit step function. Next is unit ramp. Function. So obtain Laplace transform of unit ramp. Obtain its Laplace transform. So we have to obtain here the Laplace transform of unit ramp. So first we draw the diagram and write its equation. So this is t, it is r of t, this is t equal to 0. This function is, this diagram is unit ramp signal. Now it is defined as r of t is equal to t for t greater than equal to 0. This value is 0 otherwise. Or we can say r of t is equal to t u of t. So we write down the equation for this now. X of s is equal to integration minus infinity to infinity x of t e raised to minus st dt. This is equation number this one is 7 and this one is equation number 8. We are giving continuous equation numbers, that is from the start 1 2 3 and so on. So here r of t is equal to, here x of t is r of t, which is equal to t. For range t is equal to 0 to infinity. Okay, so equation becomes x of s is equal to 0 to infinity e raised to t into e raised to minus st dt. Question number 9. Now we again recall the integration formula. We write here recall integration formula. So integration of t e raised to at dt e raised to at by 2 a square at minus 1. Okay, so therefore x of s is equal to e raised to minus st by s square minus st minus 1 integration 0 to infinity. So we just solve it. Minus sign is outside, e raised to minus st by s square, that is st plus 1 0 to infinity. So minus 1 by s square is outside, so minus st into st plus e raised to minus st 0 to infinity. Then we have to solve this equation. It is minus 1 by s square e raised to minus st into st. We just take separately the integration, plus e raised to minus st integration 0 to infinity. Okay, so we substitute values here. 1 by s square, it is st by e raised to st 0 to infinity plus 1 by e raised to st 0 to infinity. So this value is 1 by s square. It is minus 1 by s square, 0 minus 1, so it is 1 by s square. Now next is ROC. So here we write down the ROC. Draw the diagram. ROC is here Laplace transform is how much? It is 1 by s square, and it is valid for range R e of s greater than 0. That means sigma greater than 0. So ROC is sigma greater than 0. Now here the function has two poles. Function has two poles at origin. So we draw the diagram here. It is sigma, it is j omega. Here are two poles. We draw it two times here. So here double pole at origin, double pole at origin. So this is figure shows the ROC. So in this way we can find the Laplace transform of unit ramp signal. Now here we have to remember that this is a casual signal and the poles are at origin. So ROC is greater than the pole, that means sigma greater than 0. Okay. Next we have to obtain the Laplace transform of exponential function. Again there are two exponential function has two types, a growing exponential and decaying exponential. So first we will see growing exponential first. Fourth one, positive sided growing exponential pulse. So we can write here, obtain Laplace transform of x of t is equal to e raised to at u of t. First we draw this diagram. Exponential function, it is x of t, this is t equal to 0, here it is 1. So as it is a growing exponential, it will grow continuously. This is for a greater than 0. This function is e raised to a t. Now this is also called as right-handed growing exponential pulse, and such pulse is represented as f of t is equal to e raised to at u of t. Now here a is what? A is arbitrary constant. Arbitrary constant. So for a greater than 0, the nature of pulse is shown in this figure, is shown. Okay, now we have the equation x of s is equal to minus infinity to infinity x of t e raised to minus st dt, equation number 10. Okay, now here x of t is equal to what? It is e raised to at u of t. This is equation number 11. Now next is multiplication by unit step u of t. We write here multiplication by unit step, that is u of t, indicates the exponential pulse e raised to at is present, is in the range t equal to 0 to infinity. Okay, so the limits of the equation 10 will be from 0 to infinity. So equation 10 becomes x of s is equal to 0 to infinity, x of t is e raised to at into e raised to minus st dt. So this equation becomes 0 to infinity e raised to minus s minus a dt. So we saw this. So it is e raised to minus of s minus a to t divided by minus of s minus a. Integration goes from 0 to infinity. We substitute these values of integration here, and the answer is x of s is equal to 1 by s minus a, that is Laplace transform of this is 1 by s minus a. Okay, now we have to draw the ROC for this. So ROC is the Laplace transform of Laplace transform is 1 by s minus a, and it has pole as plus a. Thus ROC is RE of s minus a greater than 0, that is RE of s greater than a. But RE of s means what? Sigma. But RE of s means sigma. So we can write ROC is sigma greater than a. Now we draw the diagram for this. It is sigma, it is j omega, it is 0. Now here pole is at a, that is positive. So pole is represented by this, and it is a, and it is to the right side, greater than a. sigma is, that is ROC is greater than A. So we draw here. So this is ROC. ROC of positive sided growing exponential function. Now we have to note that here this is a casual signal and pole is at plus A. So ROC, that is sigma greater than A. So in next lecture we will see the positive sided decaying exponential function, that is Laplace transform this. Also negative sided exponential function, Laplace transform sine wave, cosine wave. We will see all these in the next lecture.